Okay, so today we're going to talk about finding the slope of a line. We're going to cover two integrated algebra learning standards, explain how slope is a rate of change between dependent and independent variables, and determine the slope of a line given the coordinates of 2 points on that line. Okay, so let's say that I have 2 points, point 2 and point 1, and I want to talk about how point 2 has changed from point 1. If you try to think about the ways to describe it, you can think about how far point 2 is away from the origin compared to point 1. That's one way of looking at it. You can say that point 2 has sort of increased on both the x and y, because point 2 is this far away. So that's 1, 2, 3, 4, 5 away, and it is 1, 2, 3, 4 up. Okay, so the difference between the horizontal distance between point 2 and point 1 is 5, and the vertical distance is 4. Okay, so what we just did was we actually found some components of what we're going to call slope. Okay, so the slope is a way to sort of determine how fast the line between points is increasing, and we can use it as a comparison tool. So let's say I have these two graphs. I have point 1 here, point 2, and point 1 and point 2 on graph number 2. Let's draw the line between the points right here, and let's draw the line between the other 2 points here. Now, slope is a way to sort of compare the rate of change for graph 1 and graph 2. So it sort of looks like the line in graph 2 looks steeper than the line in graph 1, right? The blue line looks steeper than the red line, but what do we mean by steeper? How am I determining that? Those are all questions that can be answered by using slope. So if we look, and try to understand what slope might be, if I talk about how steep a line is, what I might want to do is might want to think about how far it's gone across horizontally versus how far it's gone across vertically, or gone up vertically. So in graph 2, it's gone 2 units horizontally, where it's gone 1, 2, 3, 4 units vertically. And in graph 1, it's gone 5 units horizontally and 4 units vertically. So for the same rise, they've both gone up 4 units vertically. Graph 1 has gone up 4 units across 5 horizontal distances, whereas graph 2 did it in 2 horizontal distances. So we can see that graph 2 is steeper than graph 1 because it has gone up the same amount, but it's used less horizontal distance to do that. Okay, so if you were climbing up this hill, if you were a little person on this hill, it takes more strength to get up this hill than it does to this one, because this one is it has a more gradual slope. It's going up the same units vertically, but it's taking more time horizontally to do that. Okay, so slope is a measure of vertical change to a measure of horizontal change. It's a ratio. Okay, so slope number 1 is a ratio. Okay, oops, not a ration, a ratio. Okay, and what it compares is it compares vertical distance to horizontal distance. Okay, so in this case, we can look at the slope with your eyes. So you can think of this as being 1 measurement up vertically versus 1, 2, 3, 4 measurements horizontally. And so our slope is the vertical change over the horizontal change. Okay, and so, which is what I said over here, okay, over horizontal change. So this right here, the slope of this line would be 1 over 4. Okay, and I want to keep it as a fraction. I don't want to turn it into a decimal. I want to reduce the fraction to its lowest terms, but I want to keep it as a fraction, even if it's an improper fraction. Okay, another way of looking at this is the algebraic way, which is the change in x and y coordinates divided by the change in x coordinates. So if I had two points, which I do up here, okay, and so if I look at 2 points on this line, this point and this point, all right, and this point right here is 6, 4, and the other point is 2, 3. Okay, to figure out, because not only are you going to be able to find the slope from a graph, you should be able to also find it from 2 points. Okay, if I give you these 2 points and I asked you to find the slope of the line in between them, and you didn't have a graph to find it, you could use the coordinates of the points to find what you're looking for. So if I'm looking for the difference in the y coordinates, so let me just stack them up here. So point 1 has coordinates 2, 3. Okay, we'll call this point 1. And point 2 has coordinates 6, 4. Okay, and it's very nice to stack them up horizontally because then the x coordinates are lined up and the y coordinates are lined up too. Okay, so if I want to find the change in the y coordinates, right, I can look at the new y coordinate, which is 4, and I can subtract from it the old y coordinate, which is 3, right? And if I look on the graph, it makes sense this way because this y coordinate means that that point was 4 units from the x-axis, and this y coordinate of 3 means it's 3 units, so that's telling us this little portion here should be 1. Okay, and then I divide it by the, so this is what this is saying right here. And actually, this notation is brought on by, the points are often described as so if you have 2 different points, the first point would be described as x sub 1, comma, y sub 1. So this means the x coordinate in the first point and the y coordinate in the first point. And the second point can be described in general as x sub 2, comma, y sub 2. When you have this little 2 and it's a subscript, we call it sub. So this is the point number 1, this is point number 2. And what I just found was y2 minus y1, right? I took the y coordinate of the second point and I subtracted the y coordinate of the first point. Okay, and that was that 4 minus 3 right here. Now we're going to do the same thing with the x coordinates. So I'm going to take the x coordinate of the new point, which is 6, and I'm going to subtract the x coordinate of the old point, which is 2. Okay, 4 minus 3 is 1, and 6 minus 2 is 4. And that ratio right there is already reduced. Okay, so my slope for this is equal to 1/4. And oftentimes we write slope with a lowercase m. So m is equal to 1/4. Okay? Slope is often it's often referred to as the rise over the run. Rise meaning it's the vertical change, either up or down, and it's created a ratio with the run, which is the horizontal change. Okay, so let's find the slope of this line right here. The first thing that we do when we find a slope is pick any 2 points in the line, and we'll make the P1 be the leftmost point. So let's pick points in the line that have integer values for both coordinates. So I have a couple picked out here. So let's call this P1 and P2. P1 is leftmost, so it has a smaller x coordinate, right? Whatever that x coordinate is, it's smaller than this one because it's to the left of P1 is to the left of P2. Okay, and copy the coordinates vertically on paper. So P1 has the points 3, 1, and P2 has the coordinates 7, 6. Okay, copy them vertically so that they're stacked up on each other. That way the x and y's align. Right, that's the x column, this is the y column. And subtract and create a simplified ratio. So you're trying to do y2 minus y1 over x2 minus x1. Okay, y2 is the, it's the y coordinate of the second, so it's actually, I'll write it in purple here, it's actually this one, that's the y coordinate of the second point, so it's 6 minus 1, okay, and then x2 is 7, and x sub 1 is 3, so 6 minus 1 is 5, and 7 minus 3 is 2, and that is a simplified ratio. So the slope, or m, is equal to 5/2. Now, right here, we could have figured that out visually because this right here, the rise is 1, 2, 3, 4, 5. I can see that that's a distance of 5, and this is a distance of, oh, I'm sorry, I actually did that wrong, right? That should be 4. So it should be 5/4, and good thing I checked it visually because I caught my mistake. Okay, so it's 5 over 4. Now, a question might be, well, are those special points? Could I have picked other points and determined the slope of this line? So I just paused the video and I found 2 more points here. Let's say that this new one is P1. It's actually our old P1. And this new point is our P2. And I wrote down the coordinates. P2 is 5, 3.5. And P1 is 3, 1. And I'll find the slope using these 2 points now. So we have 3.5 minus 1. Okay, that's the y-coordinate of the second point minus the y-coordinate of the first point. And 5 minus 3, so that gets us 2.5 over 2. And if we think about that, well, 2.5 over 2 as a ratio, if I multiply the numerator and denominator by 2, which I'm allowed to do, that sort of just creates an equivalent ratio, I would get 5 over 4, which is the same as I got before. So the moral of the story is it doesn't matter which 2 points that you chose. There I chose, for the second calculation, I chose those 2 points. For the first calculation, I chose these 2 points right here. It doesn't matter what the 2 points I choose are. If you look at these two triangles are actually similar triangles. Okay, because this one has a ratio of 5 to 4 for the sides, and this is 2.5 over 2. So you can see that the ratio of side lengths are the same. Okay, the corresponding side length ratios are the same. 5 is to 2.5 as 4 is to 2, right? The numerators are always double the denominator. And in similar triangles, these the angles right here are the same. And that's really what we're judging. We're judging the angle of how fast this line is going up, which is how steep that angle is, okay? So it doesn't matter the points that you choose. You're always going to be, as long as you've calculated everything right, the slope will always be the same. Okay, principle number 1 is as the point moves from left to right along a line that is rising, y increases as x increases, and the slope of the line is positive. Okay, so if I look at this line and I look at it as I think about these points, and I look at it as x increases. So in all these points, as x increases, the line goes up. So if as x increases, y also increases. Like, look, if you think about the coordinate pairs, the line is considered to be rising. Okay, so the slope is going to be positive. So if I calculated the slope between these 2 points right here, okay, so I wrote down the coordinates of these points. This point is 2, 4, and this point is the origin 0, 0. And so this is P2 and P1. I sort of wrote P2 on the top this time, but it's still okay. The slope is 4 minus 0 over 2 minus 0, which is 4 over 2, or 2. So here the slope is 2. And I said before to keep it in a ratio, but the one exception is if the ratio reduces to a whole number like 2. You can turn it into 2. You don't want to keep that as 2 over 1. You want to write that as the integer 2. So this right here is a positive 2, and that's because when you take these numbers, when you take the difference between the new point and the old point, both the numerator and denominator are going to be positive. Well, that gets a positive slope, and when the slope is positive, the line is considered rising. Principle number 2 is as a point moves from left to right along the line. So here I'm going from the left to the right on the screen. Okay, so if I go down along the line as I move from left to right along the line is considered falling, and the slope turns out to be negative. Okay, so I picked up 2 points here. This point is negative 2, 6, and this is the origin here. And negative 2, 6 is going to be 0.2 because it's left of the origin. Okay, so this is P2, P1. And so the slope would be 6 minus 0 divided by negative 2 minus 0. So that's 6 over negative 2. So that's negative 3. So the slope here is equal to negative 3. Okay, remember that little lowercase m means slope. And so we can see when the line is falling or decreasing. So as the x-coordinates get larger, the y-coordinates get smaller on this line. The slope is negative and it's considered decreasing or falling. Okay, principle number 3 is if a line is parallel to the x-axis. So here you should be able to write the equation of this line 1, 2, 3, 4. So it's 4 up. So this line has a constant distance of 4 units above the x-axis. So it is y is equal to 4 is the equation of that line. If it's parallel to the x-axis, the slope is considered 0. And if we take 2 points, we can see why that is. So this would be P1, this would be P2. This point here is 1, 1, 4, and P2 is 2, 4. Okay, and so we'd have, let's write them vertically here. We'd have 4 minus 4 over 4 minus 4 over 2 minus 1, which is 0 over 1. Okay, 0 divided by 1 is 0. You can divide 0 by 1, you just can't do it the other way around. So here the slope is 0. So if you have a straight horizontal line, the slope is 0, which makes sense because there's no inclination on a horizontal line. If you were a person walking on this line, you wouldn't be going up a hill at all. Okay, but principle number 4 says, right here, this line is a vertical line right here. This equation of this line is x is equal to negative 2. If you have a line that's parallel to the y-axis, okay, if you try to find the slope of this line, let's take a couple of points here. Let's just take this point right here. This point is negative 2, 0, and let's take this point right here, which is negative 2, 6. Okay, and also you can't consider which one is the leftmost point. Doesn't really matter. I can sort of demonstrate what's happening here. So here are the 2 points, 6 minus 0 over negative 2 minus negative 2. Okay, 6 minus 0 is 6. And here I want to use KCC, so it's negative 2 plus positive 2. So it's 6 over 0, and this is what I cannot do. That's undefined. I cannot take 6 and divide it by 0. And I think if I thought about it in terms of inclination, this line is absolutely the steepest line you can get. Okay, so the slope is undefined, and we don't have a way of expressing how steep this line is. So geometrically, the slope is so steep that it's undefined. Algebraically, you're led into an equation where there's no change in the horizontal distance. The change in the horizontal distance is 0, so you end up having to divide by 0, which is not allowed. Okay, and that concludes our lessons on slope.